Okay, this is chapter 7.4, adding and subtracting rational expressions. The essential question for this chapter section is, how can you determine the domain of the sum or difference of two rational expressions? What you will learn, add or subtract rational expressions, rewrite rational expressions, and graph the related function, and simplify complex fractions. Okay, so let's take a look at all this. Okay, so we're going to review a core concept from Algebra 1 before we continue, because it's super important you don't make these mistakes. So it says to add or subtract, when adding or subtracting with like denominators, let A, B, and C be expressions with C not equal to 0 since it's in the denominator. If you have A over C plus B over C, that equals A plus B over that same C. You can combine them. Same with subtraction. A over C minus B over C equals A minus B over C. For example, if let A equal 3, let B equal 4, let C equal 5, for example. So A over C would be 3 over 5, plus B over C would be 4 over 5, and those equal 7 over 5, which is A plus B. Okay, same with over here. A over C minus B over C equals -1 over 5, okay, for example. All right, so when adding or subtracting like denominators, you add or subtract the numerator and keep the same denominator. Okay, so example 1 is adding or subtracting with like denominators. Let's put this practice into effect. So we have a 4x in the denominator on these. So this would simplify to 7 plus 3 over the same denominator. 4x simplifies 7 plus 3, and we are done. It is that easy. 10 over 4x is 7 over 4x plus 3 over 4x. Okay, part B. X plus 6. So we're going to keep that x plus 6 as one denominator. And we're going to take the 2x. Oops. Almost wrote a 4. I don't know why. 2x minus 5. Okay. And there's nothing more I can do with this. Be careful. You cannot, and I can't stress this enough, you cannot cancel these x's here. That does not mean -3 over 6. And I'm just going to take a minute to explain that before I go any further. So if we did cancel that, then you would say, well, that'd be 2 minus 5 over 6. This is not true, so just watch, don't write. And that would be -1/2. Well, let's plug in an x. And how about an x? How about 5? So if I put 2 times 5 minus 5 over 5 plus 6, that should equal -1/2 if we were allowed to cancel those x's. Well, 2 times 5 is 10, and 10 minus 5 is 5, and 5 plus 6 is 11, and 11 absolutely positively does not equal a -1/2. So you cannot do that. So please keep in mind that we cannot cancel the variables when there's addition and subtraction involved. So the answer to this is 2x minus 5 divided by x plus 6, and I can't do any more than that. Now you should be able to do problems numbers 4 and 6 in your exercise. Okay, another core concept, adding or subtracting with what? With unlike. They're not like denominators, different denominators. So it says let A, B, and C and D be expressions where C and D cannot equal 0 because they are denominators. Okay, so now it says A over C plus B over D equals A times D over C times D plus B times C over C times D. Okay, so what did they just do here? They wanted a common denominator. So they're making this a little confusing, but it's not too bad. Notice we have a C and we have a D. So how they got from here to here was they took A over C and they multiplied it by the other denominator, D, or D over D. So D over D right here, or actually I could have written it over here. Get rid of, whoops. Let's do that again. So it would be times D over D, right? And that would give us AD over C times D, which is CD. And that's how they got this CD here. But then we have this B over D. So then we say plus B over D. Well, I'm lacking a C. So I'm going to multiply by C over C. And that's all they did here. So they got A D over C D plus B C over D C or C D. Okay, and they put it in alphabetical order here. So if I move these, I don't want to move both. I just want to move this one to this side because all they did was put it in alphabetical order. Okay, and that is that. Let me move that little dot out of the way and put this here and put that back. So all they did was got BC over CD by multiplying by C, and then they put it in alphabetical order. Now our denominators are the same. So I can then say, well, my denominator is now going to be CD and my numerator is going to be, AD plus BC as they have right here. And the same goes with subtraction. It's just the sign change in the middle. Okay. So all we're really doing is multiplying both fractions by the other's denominator to get common denominators. And we'll look at that in an exercise example. Okay, so example 2 is finding a least common multiple, LCM. It says to find the least common multiple of these two polynomials. The reason we're doing this is we're going to get into dividing these things, or multiplying them, or adding them, or subtracting them. And when you add and subtract them, you have to have common denominators. So if this was a denominator and this was a denominator, I need to find all the factors to multiply the other by a factor to get the same common denominator. Okay, so if I do this first, 4x squared minus 16. Always look for a greatest common factor first, and 4 will go into 16, so it is 4, leaving behind x squared minus 4. And I can simplify that because it's a difference of squares. So I'm going to do this, and the square root of the first term goes here, plus or minus the square root of the second term goes here. So it's when I FOIL this or multiply it all back together, I will get the original. So I got 4x plus 2 and x minus 2 from factoring that. Now I'm going to factor this. 6x squared minus 24x plus 24 has common factor, our greatest common factor of 6. 6 will go into 24, and obviously 6 goes into itself. So if I factor a 6 out, and 6x squared divided by 6 is x squared. Positive divided by a negative, or a negative divided by a positive is negative. 24 divided by 6 is 4, and the x comes for a ride. Positive divided by a positive, 24 divided by 6. And then I simplify further because that can be factored. So factors of C that add up to B, I want factors of 4 that add up to 4, and that's 2 times 2. Signs are the same, and they have to be negative to get a sum of negative in the middle. So my greatest common factor now is just a list of all of the factors. So my greatest common factor is 4 times 6 times x plus 2 times x minus 2. Okay, I've listed everything you see here, a 4, a 6, an x plus 2, an x minus 2, and x minus 2s are over here twice. Okay, so I need an x minus 2 2 times squared. So you have to account for how many each one has minimum. So this has 1x plus 2. This doesn't have any, so I need 1. This has 1x minus 2. This has 2x minus 2, so I need 2 of them. This has a 4. This has a 6. So I want 12. This multiplies to 12. X plus 2, x minus 2 quantity squared. So this is the least common multiple of those two. Okay, so now that I've done that, you should be able to do problem numbers 10, 12, and 14. Just factor and list all your factors, and you need a minimum number to satisfy each expression. Okay, so now you should be able to do problem numbers 10, 12, and 14 in your exercises. Okay, so now we're going to go back a couple screens here, and we're going to do this here. what did they do here? Well, they multiplied the first by this to get CD. They multiplied the second denominator by this to get CD. So you multiply the denominators of one to the denominator and numerator of the other, because anything divided by itself is one. So let me explain that here. So if we have 7 over 9x squared, I want to multiply it by, let me highlight this, and I'll use purple. I want to multiply it by that. So I'm going to go back to my pen, purple, and I need to multiply the top by 3x squared plus 3x, but I also need to multiply the bottom by 3x squared plus 3x. So hopefully you can see that just the purple is the same thing divided by itself, and that's equivalent to 1. So I did not change the value of anything yet. Then it's plus, and then my other value is x over 3x squared plus 3x. But now I need this 9x squared right here. Let me highlight that. So let me get my highlighter, change it to red, and I need this denominator. I'll use my red pen. So I need this multiplied by 9x squared over itself. So that's still 1. Anything divided by itself is 1. Okay, so then I simplify this. 7 times 3x squared is 21x squared. 7 times 3x is 21x. And then I distribute down here. 9 times 3 is, actually, we could probably leave that because things are going to cancel. So let's not break that down. So disregard that. Let me just put this as 9x squared parentheses 3x squared plus 3x plus, and then distribute this, and I get 9x cubed over 9x cubed times 3x squared plus 3x. Okay. Whew. Now I'm going to combine those because the denominators are the same. Why do I have a cubed? 9x squared, 9x squared. Why did I have a 9x cubed in the denominator? I don't. You see this 9x squared? That's right here. Okay, my apologies. It's just 9x squared. 9x squared times x is 9x cubed. 9x squared times all this is just 9x squared times all that. It doesn't change. So now my denominators are the same. So I'm going to get an answer with a 9x squared, 3x squared plus 3x in the denominator. And my numerator is going to be 21x squared, but the 9x cubed is a greater power. So I put that first. 9x cubed plus 21x squared plus 21x. Okay, so now that I have a 9 and a 21 and a 21, I can factor out a 3 from all of this. Okay, so if I factor out a 3 and an x in the numerator, factor out a 3x, 9 divided by 3 is 3, x cubed divided by x is x squared. 21 divided by 3 is 7, x squared divided by x is x. 21x divided by 3x is a positive, positive 7. All over. And this here, I can factor out. So I can leave that 9x squared by itself. And I can factor out a 3x. So let me put it in parentheses. If I factor out a 3x here, I'm going to get x plus 1. And then my 3x's cancel. And then my answer is just simply going to be 3x squared plus 7x plus 7 divided by 9x squared times x plus 1. All right. Let me try that again. Okay, so there's our answer. 3x squared plus 7x plus 7 divided by 9x squared times the quantity x plus 1. Okay, so that's how you add fractions with unlike denominators. Now you should probably be able to do 20, 22, and 24 in your exercises. Okay, this is example 4, subtracting with unlike denominators. I'm just going to say in advance, just be a little careful on these, they're tricky. I'm just going to write x plus 2 here because nothing's going to change there. And I'm color coding everything. I already highlighted these. So the numerator on the left is x plus 2. I'm going to factor the denominator. I can factor a 2 out. That's going to leave me with 2 times x minus 1. And that's going to be times. And this negative 2x minus 1 just stays that for now. And I'm going to factor the denominator. So that's going to be factors of 3 that add up to 4. 3 is prime, so it must be 3 and 1. Signs are the same. They're both negative, so it's x minus 3 times x minus 1. Okay, so now we can see what we need for a GCF. We need a 2. We need an x minus 1 for each, and we need an x minus 3 for each. So this does not have an x minus 3. So I'm going to multiply this side by x minus 3 over x minus 3. Okay, multiply x minus 3 over x minus 3 is 1. So I'm going to multiply that by x minus 3 over x minus 3. And looking at this, I have an x minus 1, I have a 2, I have an x minus 3. I have an x minus 1, I have an x minus 3. I don't have a 2. So I'm going to multiply this by 2 over 2. This side. Oh, and that's not times. My mistake. This is minus. Okay, so there we have it. This fraction. And now we're going to multiply this, FOIL it. So I will put it in black when I'm done. So factoring this, x times x is x squared. X times 2 is 2x. Negative 3 times x is negative 3x. 2x minus 3x is a negative x. And a negative times a positive is negative, and 3 times 2 is 6. And then I do the bottom is going to just simply be, put them in order. 2, x minus 1, x minus 3. Whoops, forgot the minus. 2x minus 1, x minus 3. Minus, and then I multiply this 2. 2 times a negative 2 is negative 4. 2 times 1, negative 1, is a negative 2. I forgot my x. So it's negative 4x minus 2 over this same denominator, 2 x minus 1, x minus 3. Okay, so there we have it. Same denominators now. Now I need to subtract and change all these signs. So I'm going to just get x squared. Negative x minus a negative 4 is plus 4x. So negative x plus 4x is plus 3x. Negative 6 minus a negative 2 is negative 6 plus 2, which is negative 4. She got it right. Okay, so now this is going to be all over the same denominator. Okay, so because when you subtract the numerator and keep the same denominator, and there it is. But I can factor this. So now this x squared plus 3x minus 4 equals, and I can factor this. Factors of 4 that add up to 3 are again 3 and 1. And that is going to be a positive 3. I'm sorry, not 3 and 1, 4 and 1. Factors of 4 are 4 times 1 or 2 times 2, but I need a sum of 3. So it's going to be plus 4 minus 1 all over 2 x minus 1, x minus 3. Now you can see that this is all multiplication, and that's when you can reduce by canceling. x minus 1 divided by x minus 1 cancels, and we end up with x plus 4 over 2 times x minus 3. And this is the simplified difference of those two polynomials. Okay, and then we also have to restrict our domain. So x cannot equal 3, comma, x cannot equal 1. Okay, and the book only said x cannot equal -1, but it's x cannot equal 1 and x cannot equal 3. So that was an error, I believe, in the book. Okay, so this is the answer here. So now you should be able to do problem numbers 21 in your exercises. Okay, example 5 is rewriting and graphing a rational function. It says to rewrite the function g of x, which equals 3x plus 5 over x plus 1 in the form of g of x equals a over x minus h plus k, and graph the function. Describe the graph of g as a transformation of the graph of f of x equals a over x. So let me get some graph paper. Okay, so there's two ways to do this. The book shows one way, and I prefer a different way, but I'll show both. So if g of x equals 3x plus 5 over x plus 1, then we can rearrange the top by saying 3x plus 3 plus 2. Because 3 plus 2 is 5, this does not change its value, and put that over x plus 1. So if you think of this as 3 plus 2 in parentheses gives us the 5, and we move the parentheses because in addition, if we move parentheses, that's the associative property of addition. Now I can put the parentheses here, and that would factor out a 3 times x plus 1 plus 2 over x plus 1. Okay. So then when I split that up, that would be 3 times x plus 1 over x plus 1 plus 2 over x plus 1. And then the x plus 1s cancel here, and leaving me with finally getting 2 over x plus 1 plus 3. So our h equals -1 and our k equals 3. So keep in mind that your h is your vertical asymptote. So then I would draw that. Let's see. Let's go like this, go like this, go like this, go like this, go like this. And I have h is -1. So that's right here. It's a little bit thick. I'll fix that. Doesn't really matter. All right, so let's click on that. And no, make that a little thinner. That's good right there. Okay, and I'm going to obviously put arrows at the end. And this is x equals -1. Okay, vertical asymptote at -1, and then the k is your horizontal asymptote. So I'm going to do the same thing here, pick a line segment, actually put arrows at both ends, make it dash, make it thin, make it green, and put it at 3, which is right here. Make that a little bit thicker. It's probably hard for you to see, especially if you're using a phone. And let's do the same with this. Okay, and then I'm going to label this as y equals 3. There are vertical and horizontal asymptotes. Now I'm going to stop there. Actually, let's just graph it while we're at it. So if I'm going to work around 3, I want to know what values are around -1. I want to know what value the function is at -2. So if I put a -2, I'm going to look right here. Put -2 in here. -2 plus 1 is -1. 2 over -1 is -2 plus 3 is 1. So at -2, we are at 1. How about I do a table rather than just say it? Okay, we already know that when x equals -1, it is undefined, and that's because of the asymptote. And if I go -2, -3, -4, 0, 1, 2. So -2 was 2 over -1 or -2 plus 3, which was 1. Put a -3 in here, we get -2 over 2, which is -1 plus 3, which is 2. Put a -4 in there, and I get -2/3. So 3 minus 2/3 is 2 1/3. So let me graph this side first. So -2, 1 is already graphed. -3, 2 is right here. And -4, 2 1/3 is here. So this function is coming down like so, and it's turning and going up like that. So that's our left side of our hyperbola. Now we do the other side. If I put 0 in here, it's 2 over 1 plus 0, or 1, which is 2 plus 3 is 5. Go over 0, up 5 is right here on the y-axis. Plug in a 1, and I get 2 over 1 plus 1, which is 2. 2 over 2 is 1. 1 plus 3 is 4. That's the point 1 comma 4, which is right here. And then finally plugging in 2, I get 2 over 2 plus 1, which is 3. 2/3, that'd be 3 2/3. So I'd go to 2 and up 3 and 2/3, which would be about here. So this function is coming down like so, turning and approaching that asymptote, but never getting there. So this is the graph of g of x. All right, now let me go back and show you a different way to do this. Let's start over. And g of x equals 3x plus 5 over x plus 1. The other way you can do this, and this is my preferred way than to try to figure this all out, is I just take the denominator and divide the numerator by it. We've done long division before in earlier chapters this year, so this is nothing new. So we're just asking ourselves, x times what is 3x? Well, it's 3. So 3 times x is 3x. 3 times 1 is 3. And we subtract this. And we get 3x minus 3x is 0. 5 minus 3 is 2. Well, I can't put an x in 2, so this is my remainder. So when you do a remainder, you say plus your remainder over what you were dividing by. And then this is just backwards. So that becomes 2 over x plus 1 plus 3. And that is still g of x. And notice it came out the same. So this is the same as this. I really prefer doing it this way than trying to figure out what I need to break the constant down to so something will factor to match the denominator. Either way you want to do it. If this works for you better, that's fine. So then it says, describe the graph of g as a transformation of the graph of f of x equals a over x. Okay, so in our case, our a is 2. And what did it do to the function 2 over x? Well, it shifted left. One unit. And shift up k units, which was 3. So it's shifted left 1, up 3. So here's my origin. So I go over 1, left 1, and up 1, 2, 3. And I'm right there. Okay, so now that I've done this, you should be able to do problem numbers 32 and 34 on your exercises. Okay, complex fractions. A complex fraction is a fraction that contains a fraction in its numerator or denominator. A complex fraction can be simplified using either of the methods below. So to simplify them, method 1 is, if necessary, simplify the numerator and denominator by writing each as a single fraction. Then divide by multiplying the numerator by the reciprocal of the denominator. Method 2, multiply the numerator and the denominator by the LCD of every fraction in the numerator and denominator, and then simplify. Okay, a lot to say, but might not still understand. So let's do an example that shows an example of what they're trying to explain in this core concept. Okay, so simplifying a complex fraction is example 6, and here one is. Look at this, a fraction divided by a fraction plus a fraction. There's a lot of fractions here. So here's what we're going to do. We're going to focus on the denominator first. Just ignore that 5 over x plus 4 for now. So when I do this, let's do it in, I don't know, blue. I need to get common denominators here because of this plus sign. So I need an x over here, and I need an x plus 4 over x plus 4 on this side. Makes sense because we've been doing this. And this is going to give me, so let's bring down my 5 over x plus 4. It's just waiting, kind of like when you make a phone call to a company and they put you on hold. So that's just sitting there waiting while I take care of this other customer in the denominator. So x times 1 is x. X times x plus 4 is x times x plus 4. Don't put those together yet. Okay, and then it's going to be plus, and then I distribute this and I get 2x plus 8 over x times x plus 4. Okay, so right now it makes it look like it got worse, but actually it got better because now I can add my numerators. So again, this guy's still on hold up here. X plus 4, he's listening to elevator music. It's all good. Okay, and then x plus 2, x plus 8 is 3x plus 8 over x times x plus 4. So see, it's already gotten better. Now it's a fraction divided by a fraction. Okay, so then I'm going to multiply by the reciprocal. So now this is going to be, I'm going to still take 5 over x plus 4, but I'm going to switch it to multiplication. And I'm going to put that x times x plus 4 in the numerator. Like so, divided by 3x plus 8. So it's 5 over x plus 4 times the reciprocal of the denominator, which is what it basically said right here. Okay, multiply the numerator by the reciprocal of the denominator. We're doing method 1. All right, so now this is all multiplication. So I can multiply all this. Well, now it's going to be, let me just go across here. 5 times x is 5x times x plus 4 over 3x. Whoops. I have to multiply the bottom. What am I doing? Okay, let me put parentheses around this and we'll factor it. X times 3x is 3x squared. Actually, no, I don't want to do that because look at these x plus 4. So I'm going to put 3x plus 8 here and x plus 4 over here. And look what happens. The x plus 4s go bye-bye. Okay, and then this becomes 5x divided by 3x plus 8. Okay, and we're done. So let me put my answer in a box. There's my answer. Don't forget to restrict your domain. So anything that's in the denominators cannot be. So I cannot let x cannot be -4, comma, x cannot be -4 again, and x cannot be 0. Okay. And I'm going to take that one step further. What makes this denominator 0? Well, x cannot be, the book did not say this, but this cannot be -8/3. Because 3 times -8/3 is -8 plus 8 is 0. Can't get 0, can't divide by 0. So x cannot equal -4, x cannot equal 0, and x cannot equal -8/3. So there is my final answer with my domain restriction. Now that I've done this, you should be able to do problem numbers 40 and 42 in your exercises. Woo, okay, finally, that brings us to the end of chapter 7.4. That was a lengthy lesson. So do these problems in your exercises. Thanks for watching and have a great day.